y'all? Darryl Jr. back as promised for a special show to talk about how I did the last semester. And everything is different as far as tried to set it up as much as I could, but I'm in my new dorm, my summer dorm now. So I had to move everything over the weekend. Like you were saying, Catherine had a busy weekend. I was expecting them because I'm staying on campus for the summer, but I also, when you graduate, there's something called extended stay where the people who are not actually living on campus for the summer, they can still stay in their dorm until the week after graduation, which would be today, the 11th. So the last graduation was on Saturday, the last ceremony. So I thought I was going to have until Sunday to move, but I got the email like what Wednesday, Thursday, Friday, something like that. So like in the middle of getting ready for the graduations and going to the graduations and stuff, I'm moving. So it was craziness. But I got everything here, and after moving like most of the day, a little bit of the night, and got everything set up again. So it's pretty cool, and everything seems to be working okay. And had a good semester. Let me go straight to the screen. And those who are watching, let me know if you have any questions or comments. But this is my grade layout. So if you look at this is actually a screenshot from my grade report. So they give you a grade report that you can see at the end of the semester. So you can see at the top. I got this earlier, uh, a few minutes ago, so that's why it says it's current as a 511. You see, it says University Honors up top because if you make, I believe it's at least a 3.5 GPA and at least 45 grade points, you get University Honors. So, and it's just no easy way to um, show this, but what I'll do is just edit the actual image a bit. So if you look here, that's what I'm looking at for the honors. And if you look here, you'll see I had 45 grade points and with a 3.75 average for the semester. So I got pretty good about calculating my GPA and everything. So I already knew what everything was going to be, provided my conclusion about my grades were okay. And everything came through as expected. But we'll get into that. So yeah, so that worked out pretty well. So university honors, so this is my third time getting university honors. Some of y'all probably saw on one of the debates I did. I had two at the time. I put it in my little slideshow. I had two university honors. So the last one was fall of 2024. So whatever debate or something I did since then. Maybe I only had one at the time. I don't know. But suffice it to say, now I have three total. So that's pretty cool. And so let's talk about the classes a bit. Now, of course, a lot of the details of the classes you all know about because you all were did a lot of the um studying and problems and things I was doing right here. So a lot of y'all saw some of the stuff that we were studying and things like that. But going down the list, so relativity. We'll talk about relativity first. Um, you know, love that professor, Dr. Massner. He's a pretty cool guy, pretty laid back. The class actually played to my strengths because a majority of the grade was writing a paper. So I had to write a paper on a topic related to relativity. So some of y'all remember I was reading the Michelson-Morley paper because that's something that I talked about a bit in the past but didn't really get into detail about. So this time I actually uh, read the full paper, got into detail, did the derivations. I put some of that in my paper explaining the experiment. Then I actually talked about interferometry and in general and as far as LIGO. So I did some research into LIGO because the professor let us submit a draft and he gave us some feedback on the draft and he said, what you can do is talk a bit more about the differences between the Michelson-Morley interferometer and the interferometers that they use for LIGO. So some of the obvious differences is the size. Like the ones today are kilometers long, whereas the Michelson one was only a few meters long. Another thing they do is they have these mirrors that reflect and pass light in such a way to where they bounce the light back and forth 100 times in the arm of the interferometer, which increases the power of the laser, which allows them to get more accurate measurements and more detailed measurements. Now they can measure fractions of a atomic nucleus width of wavelengths of gravitational wavelengths. So that's pretty cool. And there's a whole lot of other details that I don't even recall right now. That's basically relates to more power, more precision. Uh, 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 so it's pretty cool. Pretty cool learning about it. So I wrote about that. Wrote about the interferometer. Wrote about the discoveries that they made. And actually, everything. So often things worked out with when I was writing papers. Like there was this guy who specializes in LIGO at UT. He's a postdoc, if I recall. And he actually gave a talk the day before the paper was due. So I went to that talk and I was able to see his presentation and get more information about, for instance, he was mostly looking at, well, I mean, whenever you do interferometry for gravitational waves, you look at large bodies. But he was looking at like like black hole collisions as well as trying to discover any other exotic matter out there, seeing if it could tell us about dark matter. And and he actually showed some of the equations that they use to do various things, which actually gets quite complex in certain things. But one of the equations that stuck out was he gave the equations for the uh, uh, if you have an event, um, they basically categorize the event by several parameters. So one of the parameters is the location of it. And with that, we have our ascension, our right ascension and declination. We have our distance, uh, and also the orientation of it. So if you have two things that are merging, they merge in a sort of plane. If you have two things orbiting, any orientation they're at, you could say there's a plane going through the two things. So they capture the orientation of it and all of these things and these factors go into their readings because if you look at something that's rotating around another body, you will read a different speed if it's rotating like this versus if it's rotating like this. Well, in this case, you won't even, if it's perfectly horizontal, you won't get any speed. But if it's at a certain angle, you have to take that into account, which I recall from things like when we get the rotation of stars and we're like if you're using a transit method or something like that, or I guess I should say a revolution of a planet around a star or another star around another star, the orientation of the star will determine the how much of that velocity you get. So you have to use sine or cosine to take that into account and to get the full value because you're only going to get a fraction of it depending on how it's angled. So he was showing how they do all of that to uh, pinpoint these things in the sky, and he has several other equations and experiments. And another thing he mentioned as well that I mentioned in my paper too, the LIGO, they have thousands of sensors all around the LIGO, and these sensors actually measure the local environment. Like there's so many things that can impact the experiment, like the temperature, if there's the changes in weather, if there's other things going around that's causing vibrations, they have to take that into account. And he actually showed some of the calibrations they do where they take the background noise and subtract the background noise from the data they're getting from gravitational waves. And they use like mock data to compare and basically improve their precision on being able to extract the noise while leaving the actual data alone. So a whole lot of stuff goes into that stuff. So it was pretty cool learning from him, and I was able to incorporate some of that stuff in my paper, use that talk as a reference. So it was pretty cool. So it was a pretty good paper. I got an A on the paper, and most of the homework I got an A on. I think most of it was pretty straightforward. Uh, Some of it was classical as a sort of compare to the relativistic stuff. And the relativistic stuff, sometimes I didn't do quite well on, but enough to where I got average, like a E minus or something on all the homework. And with my paper and everything, I got an A out the class, so that was cool. But I'm pretty sure I still have to do some more research on relativity to fill my background up. Thanks, appreciate it. Now, cosmology. You see that there's a Q on cosmology because I dropped that class. I may have talked about it before, but that was like, that must be the most horrible professor I've ever had in my entire undergraduate career. I mean, the dude, his slides were confusing. He had like his slides for his lectures was literally hundreds of pages long. It was hard to keep up with. He would change a few things each day, so you ended up downloading them several times, and it was just following the lectures was difficult. Then he would not give any solutions to anything. Apparently, he mentioned something to the effect of not wanting the solutions to get out there, and people apparently there's these solution sites where people can put their solutions and things like that. He was so worried about, and maybe it was part of it was didn't want to actually have to rewrite a new homework every year or a new test every semester or something. So you want to use the same stuff. So he didn't give you any solutions to anything. So we didn't know, like, and even I guess he instructed the graduate student that was grading our homework and stuff not to give us any details. So we were able to go to his office hours or discussion session and get an explanation, but it's hard to get all the details when you're trying to stuff all 5 problems or whatever in 1 hour, and it's just not ideal at all. So, like for instance, studying for the first exam, I started a study group. Oftentimes, I leave study groups. So I started a study group and said, look, why don't we get together? I imagine between us, somebody should have every problem right, and then we can make our own sort of solution sheet. Wrong. We got together. There was no problem where anyone got 100% right. The most we got was around 70 or 80% right. And I mentioned the TA's grading because when you look at the TA's grading, he didn't tell you what you did wrong. He would just say wrong, not correct, not close, or so it's close. And he would just say stuff like that. And I brought this to his attention. And I was like, we don't have a solution sheet. I mean, he's like, well, look at my comments. And I said, your comments just say wrong, wrong, wrong. What am I supposed to do with that? He was like, oh, well, I think he mentioned something like the professor didn't want him to give details. And I think the TA was a good guy. I liked him. He seemed to be, he was just doing what the professor wanted him to do, I guess. But it didn't help us, right? So then when we got to the first exam, this exam was at least 10 pages long. It was like, it must have been more. I mean, it was crazy long. It was like 10, 12, 15 pages, multiple problems on each page, front and back, if I recall, and we could not use a calculator. And I'm thinking, okay, it can't be that bad. He must want a lot of, you know, concept type stuff or something, dude. We talking galaxies are coming together and logarithm this. I mean, it was legit problems that, in my astrophysics course, we would actually solve with a calculator because, I mean, you have logarithms and multiplying, you know, things on mega orders, and it was crazy. And me and the guy next to me, we looked at each other like what the hell is going on? So I literally walked out the exam and went straight and dropped the class. So I was like, dude, this is just a waste of time, really, trying to make up for the fact that we're not given the information we need to succeed. I couldn't see myself passing that class unless it was a giant curve, and I wasn't learning anything anyway because I couldn't follow his lectures. And when I walked out, people thought I did super well or something. Like I walked out, I went straight to my advisor and I dropped the class, which was scary because I needed that class technically for my astronomy degree. But thankfully, since I'm doing 2 degrees, I had enough credits that I was able to use my relativity class. Because doing 2 degrees, you have a whole lot of classes for 1 degree that's more than for the other degree, and there is some crossover. But still, each degree has their thing. So the advisor looked over everything and saw that this class fits the parameters, like the marks you have to check for the things you have to learn, and half the class was cosmology because you're dealing with relativity, Then we started dealing with black holes and different spaces that you calculate the metrics in, and it was a lot of cosmology in it for the second half of the course. So they're like, okay, so this was specifically what you took for physics, but it overlaps. There was enough of an overlap where it met the criteria that I needed to fill that gap, and everything worked out. But if I'd have stayed in that class, it would have tanked my GPA, or it would have been a big giant curve, and I wouldn't have learned anything anyway. But there's no guarantee he was going to do some kind of curve, and then it was just nothing but stress wondering what's going to happen. I just dropped the course, so right away, and I would just look, I'm gonna have to do something in the summer, whatever I was got to do is got to do. I just knew I had to drop that course. Um, and by the way, a funny thing, when I was coming out of the advisor's office, other people were coming down from the exam, and they were complaining about the exam as well. And we commiserated about the misery of that class, and we was agreeing on how it's fault of how the lectures. The lectures are crazy. We don't have any solutions. We don't know what we're doing wrong. We don't know. It was just crazy. And one of the people, I mean, there was an advanced person, an advanced degree person in the course who was taking it for fun, and he was like, "This is crazy." So yeah. So and apparently a few other people dropped the course. One lady was talking about how she was going to just rail them on the class review. They give us a like sort of review that we do that I meant to do, by the way, but I also focused on my classes the deadline went past. I didn't actually do one on any of my classes this semester. But once you drop the course, you don't get access to it anyway. But that was that class, so that's why I dropped that one, and I'll just have to do some cosmology studying on my own. But I kind of always knew I didn't quite like cosmology anyway. Uh, as far as wanting to focus on research, but cosmology is a lot what I'm going to be doing in graduate school. I'll talk about that Saturday. So, could have studied the textbook on my own. So quantum two. So y'all know we talked about quantum two a lot. Ended up getting a B. The entire first 70% of the class, I had an A. I had an A on almost all the homework. I had a 91, or was it an 89, something like that, like an 89, 90, 91 on the first exam. But then when it got to the second exam, I think because I was focusing so much on my other courses and I was doing a lot of research, I was giving presentations. I went out of town to Maryland and gave a talk, and all of this stuff was going on. I was just behind, and for the second exam, and I told the professor, "Look, I'm going to do horrible on this exam." I kind of just skip it because this syllabus said if you miss one of the exams, then it'll just increase the value of your final exam. And I asked him that. He was like, "No, you should still just take it just to help get some practice or whatever." And I was like, "Oh," and I asked, "So the grade, you mean that the grade of the final is going to overwrite the lowest exam?" And he said, "Yeah." And I checked the syllabus and it did say that. I just missed that line. So I took that exam, got a 20, and but I knew I was going to do horrible. And but I knew that if I did well on the final and I calculated what I needed, I did so well on the first, what, 70, 80% of the course, that if I got a 20 on the final, if I got the same exact grade, I would get a C out of the class. And if I got a 40 out the final, which would overwrite my second exam, I would end up with a B out the class. And if I got a 70, I would get an A out of the class. So I made a goal to get a 70. Ended up getting a 58, which means I got a B out the class. So the last half of the class got very conceptual. I can't say I'm so good with the conceptual questions. Like y'all know, a lot of the homework problems I did on the stream, it was like solving things. Like you're giving this and what happens if this happens, but purely conceptual stuff. I don't know. I guess I got to get used to it. I don't know how much I'm gonna have of that in graduate school. But the second exam was conceptual, and the whole final was conceptual. And he actually told everybody that the grades were actually low on the final, so he did a curve on the final, and with the curve, I got a 58. So I was like, what, 12 points away from an A. He didn't do plus minus. He just did A, B, C, D, E, F. He didn't do like A plus B minus or whatever. But still, I'm happy. Quantum is still my weakest subject. Uh, so there you have it. So gotta be out that. Now, thermal. So thermal was actually my favorite subject this semester. Probably partially because we know that the flat earthers talk a whole bunch of nonsense pretending to understand thermo. So it was nice to be able to actually get some authentic understanding of thermodynamics. So I can say at this point, I do have at least a basic understanding of thermodynamics. I did very well in that course. Almost all the homework, I got an A. The last homework, I got 100. Um, every exam, I got at least a B or a C. But he gave us the opportunity to redo the exam to get half the credit back, which means that when I did that, like I got a B or a C the first time, and you can actually redo the exam and turn it in as almost like a homework project, but you have to like go in very much detail. You have to like, and y'all saw some of my drawings where I made drawings of everything, and like you can see a cylinder and this, and I drew like a diagram of the heat engine and stuff like that. You have to draw diagrams, go into detail about the concepts, do the problem. You have to do everything in detail. And if you did that, he gave you 50% back. So even though I got a C or a B initially, I ended up getting a B or an A when I got my 50% back. But that process allowed me to get a much deeper understanding of it. And then for the final, he was pretty. He's a very clear professor, very straightforward. You knew what you had to do. Some of the problems that we did was from the early exams, and then the last third of the class was new material that we didn't test on. But I had the homework to practice with, so I got in that exam. I absolutely murdered that exam. Like that exam didn't know it was coming. The only problem I had to think about twice was I mentioned with you all before the last problem where if you have a fermion, which is like an electron, and if you have a boson, which is like, I still forgot to look and see what actually a boson is, but so a fermion, if they're in the same space, they have to be in different states. The fermion, a boson, they can be in the same state, and there's a sort of probability function that you use to calculate the probabilities of these particles having different energies. And he wanted us to find out at basically what temperature they will share the same probabilities. And I got near zero, which makes sense because they're exponential. And you put a zero in both of them, they end up with one. And but I believe that's the one I missed points on. Maybe I missed points on the true and false. But after the exam, I met with some of the students afterwards, and we talked about the true and false. And me and another guy had the same answers for it, so I feel confident about it. So I think in the last one is what I lost points on, but I don't know. I'm pretty sure I could go get the final, but I didn't really worry about it because it was the final. It was you'd have to. He's probably not on campus anymore. I don't know. I actually went to his office one time to see if he happened to be there, but I don't know where he lives at. He's probably just back at home, whatever, since the semester ended. So I don't know exactly where I lost my few points at, but I ended up with a 90 something on the final. I got 31 out of 34. So whatever that ends up being, I think 91%. So yeah, so that was an A. Everything else I had in pretty much an A. So got an A out the class. Plus I did all the extra credit too. So yeah, ended up with a nice A out that class, and I learned have a pretty thorough understanding of the basis of thermodynamics, mostly the first and second law. We talked about the third law. So the first law is how the internal energy of a system will change based upon the work you put into the system and the heat you put into the system. You probably remember me making drawings where there's a piston and there's a candle underneath it. So the piston compresses it. That's the work. The candle's adding energy. That changes heat. That changes the internal energy. That's the first law. Very big part of engines, power plants, things of that nature. And the second law is thanks, appreciate it, Catherine. And the second law is the S equals K, the Boltzmann constant, times the log uh, of the multiplicity of the system, contrary to the incorrect equation that um, Flato had showed, which um, looked a bit weird to me, but I wasn't solid enough in thermodynamics myself to recognize it just wasn't the same equation written a different way. That's the second law, and a lot to do with well engines as well. Like so, I did the derivation on our stream where how entropy deals with the efficiency of engines because the entropy has to increase overall. even though the engine goes back to its original state. So entropy will limit how efficient the engine will be. So I did that derivation with y'all. So those are the two laws I'm most familiar with, the first and the second. There's also a third law that we did a bit of, which basically deals with the idea of absolute zero, and is there still energy or movement at absolute zero? I can't say I really understand that law too much. Yeah, I found him to be perhaps the most dishonest, manipulative person that I've ever met or interacted with. He's definitely up there. Just from that talk, when he accused me of being condescending when I suggested he's just repeating a meme or something when he was talking about the second law of thermodynamics. I invited him on for the express intention of actually explaining it, since apparently he's saying he does know. I showed that image of the email where I made the offer to him, and all he did was spent the whole time avoiding. I don't know where he got the equation he had from. He lied and just pulled up a random link from Harvard or MIT or whatever it was. I guess to try to fool people into thinking he had from a valid source. And then he was on this stream bragging that I couldn't find the equation in the paper because it wasn't in the paper. I guess he just found a random link somewhere. Maybe he just did a search thermodynamics MIT and just found a random link and posted it. I mean, it's crazy. And oh yeah, we debated on modern day debate. What happened is it was supposed to be a it was supposed to be a flat earth debate. What happened is uh James had mistakenly thought that one of the other guys was a flat earther, but he wasn't. So it was Flat Zoe and it was the other guy, but the other guy wasn't a flat earther. And we figured this out right before the show was about to start. So it was like 5 or 10 minutes before the show was about to start. We all get on the Zoom and we're talking about, okay, who's going to talk first, who's going to go second. And the guy was like, well, it's kind of odd because I'm not a flat earther. So what happened is, we were like, okay, what are we going to do? So we decided, like, all of the guys, I guess they debate the moon landing. And I was like, dude, I don't know anything about the moon landing. I can't debate that. But all of them was like, well, we could debate this. I was like, I'm cool with it. I just don't know. I just don't know this subject. I mean, I got to say a little bit what I know. So it ended up being a debate about the moon landing. So if you go to modern day debate, you'll see there's a debate on the moon landing with me and FTFE versus Flat Zoe, and I think the other guy's name is Marcus. Uh, but again, you know, I don't really have research on that subject, and I think the 2 points I had, which is basically this stuff I heard or saw, around. The Marcus guy was like, no, that's wrong. I was like, well, it could be, but here's just other thing. I don't really have any points on that. But but in Flatzo's opening, he mentioned we can't have outer space because of the second law of thermodynamics. So when it came to our back and forth, I challenged him on that, and he just kept saying, "Oh, well, there's no container." I kept asking, "Well, what equations are you using?" You saying the second law of thermodynamics, and again, this was well before I took thermo. This was like last year sometime, so I didn't know the details myself, but I knew that thermo is based on equations. So I'm like, "What equations are you using?" You saying the second law of thermodynamics, and he just kept going back to the same, uh, uh, you know, what do you call it? Meme that they say, oh well, if you have a container, you take the lid off and the vacuum is next to it, it escapes, So, and I said, sounds like you're just repeating something from a meme. And you say, why are you being condescending? He accused me of being condescending. So that's why later I was trying to have a debate with him on thermo, because I knew I was going to take the class in the spring. So I was like, hey, it'd be a good way for me to study, preparing for the next course. And I talked with James, I talked with him, but James was like, that's too specific, that's too niche for this channel. And I was already starting to not even want to talk to people anyway. James was like, that's too niche for this channel. Maybe you could come on for another flat earth or something. But I ended up eventually telling him, look, I don't even want to talk to these people anymore. But suffice it to say, we wasn't going to debate that on modern day debate. So I said, I contacted Professor directly. I said, look, why don't you just come to my channel and you can go ahead and present your understanding about how the second law of thermodynamics means we don't have a atmosphere, and I'll challenge you on that. And he was like, okay, so that was the purpose. He was supposed to come on and present this is why the second law of dynamics is, and so on and so forth. But the whole time he spent trying to turn it on to me, and avoiding. And then when I finally got him to pen and give an equation, he lied about where he got the equation from. It wasn't the second law equation anyway. I thought it was the equation written because I kind of like rush read the first two chapters of the book, before we talked. So I was familiar with it, but I just rush read it, and I wasn't. So I thought, okay, maybe that's the equation, and he wrote it a different way. I just gave him too much credit. I just didn't realize how much of a liar he is. So apparently, if you give him any kind of leeway or credit or any kind of the reasonable, expectation we have with a normal person that they're just basically generally honest about just simple things, he's going to use that against you, and that's what he did. So, so in the end, he just kept trying to turn it on me. After like 30 or 40 minutes, I finally got him to give the equation, and I asked him, "Where did you get it from?" He tried to avoid that. He must have just found some random link. He saw me scrolling and trying to find it in the paper. I was like, okay, well, it's going to take a while for me to find it. But then I went to his channel. He was bragging about how it's not in the paper. It's just crazy. I gave a little. Just look at my realizing the shape show. The last few I did, I was talking about that, and you could see me show the image where we agreed he was going to explain it. You could see what he was doing. I just found him to be one of the most honest, manipulative people ever, and which also motivated me to never talk to these people again. Definitely never talk to him again. And so I just banned them from my Discord because I was like, I mean, how are you going to have a conversation with somebody just so dishonest? And that was that. But then, I've actually taken thermo. Now I have a pretty good understanding of it, and so it's pretty cool. So that's that. So I got an A. Um, and then there's building scientific apparatus, where what I did was I built, basically what they wanted us to do was uh, build a device that will be utilized in the classes with the undergraduates to demonstrate a physics concept or to help with the lectures. And I was a learning assistant for electrodynamics several times, so that was on my mind. I also like classical dynamics, so I decided to make. First, I was making a demo of the Cavendish experiment, just a model, but it was going to be just a small thing you can put on your desk and just describe what it looks like. It's too small to be practical, but the professor was like, I do want something that's sort of practical that you can do. So then I also I made it into you can do a Coulomb experiment as well and try to make it practical. Whew, that was difficult to do. What I ended up doing was arranging a situation where I had a aluminum pendulum, and I had some capacitors that I can charge, and I set it so that you can take the pendulum and slide it close to the capacitor, and you can see the Coulomb force suck the pendulum into the capacitor. So in that one thing, you can demonstrate capacitance. You can calculate how much capacitance the capacitors have. You can see the Coulomb force and calculate that. It was pretty cool. When I showed it at we had to write a paper. We had to actually build a thing. We had to present it. And I went to the presentation, and people really enjoy it. I mean, it's sort of game out of seeing how close you can get the pendulum to the capacitor before it sucks in. And if you get it perfectly right, you can see the pendulum sort of hanging towards the capacitor. I was only able to get it perfectly right a few times. But it was pretty fun and it was pretty cool. The professor was really happy and excited on the reception it had. Uh, of course, we had to do things throughout the semester, like make a poster board, show our lab notebook where we kept notes of what we were doing and so forth. But I got an A on everything, so that was my last A. So thus, I ended up with 12 hours, uh, 3.75 for the semester, and my NGPA ended up being 3.62. So I graduated with a 3.62, 3 semesters of honors. And my degrees, as you can see at the top, are Bachelor of Physics and a Bachelor of Astronomy. So there you go. So that's my last semester in my overall undergraduate. So it's pretty cool. And perhaps now would be a good time to show my little walk. Me and Catherine was chatting earlier, and she saw it earlier. But let me actually load that really fast, and y'all can see it as well. My little walk across the state, um, College of Natural Sciences uh, ceremony. So I knew I heard they were streaming it, So I was like, awesome. So what I'll do is I make sure to look at the camera and give the hook'em sign, which is our at UT, we have something called hook'em. Our mascot is basically a longhorn cattle, and it's basically like a sign that's saying, like really try hard, really do your thing, or really get the competition, hook 'em. So I looked at the camera and did a hook 'em because I knew I couldn't see the camera, but I knew it was out there somewhere. And let me, oh, and I can give you, I just see your message right now. I can give you the link as well again in the direct chat. So yeah, it's kind of odd finding a chat for the Astro group
Want
thing
to
if
try
I can be,
Ozempic?
oh, hold on, it's commercial. Let me mute this while it's commercial, get past this commercial thing. But and I'll put the link in the stream as well, thinking about it. That's the link right there in the stream. I'll link it to you directly as well, Kat. There. All right. And let me share this. Boom. Oh, oh. I need to, I guess, move this around a bit. Hold up. And need to undo this. There we go. All right. So here we go. Y'all can check this out momentarily.
Darryl Edward Barry Jr.
All right. So that's me walking across the stage right there in our College of Natural Sciences ceremony. The link again is in the live chat right there. I'll put the link in the description as well, thinking about it. So I'll put the link in the description so y'all can see it. But yeah, that's me walking across on one of the graduation ceremonies. And I had four ceremonies. I had one for astronomy, one for physics. Specifically, the departments had a sort of graduation celebration. This is for the College of Natural Sciences. So all of the degrees in the College of Natural Sciences were at this one, which includes computer science, mathematics, physics, astronomy, engineering, and so on and so forth. And then there was one that night for the entire university, which apparently was 13,000 students that graduated, something like that. 1,300, no, 1,300, not 13,000, 1,300 students. And with all the degrees. That one did, there is a recording for that one, but for that one, they just asked the entire college to stand up. So everybody who was at this one that you're seeing there on the screen, everybody stood up at one time, and it was like, "Oh, I confirm that these people have met all the requirements," and so on and so forth. What is the one? And by the way, if you look at what I'm wearing there, there's a whole lot of cords. So the yellow stole, the yellow ribbon, is yellow for the College of Natural Sciences. One of those cords I'm wearing, one of them is for undergraduate research because I did my research, I did presentations on it, I presented here on campus a few times. So when you do undergraduate research, you do a presentation at some of the research events, you get a cord for that. One of the cords is for the McNair program. I graduated with the McNair program. One of the cords is for astronomy. It's a blue, like a sky blue cord. And two of the cords is for the Tau Sigma Honor Society. So when you get a certain, if you get a semester with uh over a 3.5 or a 3.6 GPA, and you have at least so many hours, you can get an invite to the Honor Society. So I got into the Honor Society, and their colors are burgundy and gold. So I had two cords for that Honor Society. So that's all five of my cords: astronomy, undergraduate research, McNair, and two for the Tau Sigma Honor Society. And you might not be able to see it, but the tassels I'm wearing two, one for each of my degrees. So I have one tassel for my astronomy and one tassel for my physics. So thanks, Catherine. I appreciate it. Yeah, it was pretty cool. So that was nice. It was fun. So that was that. So that's my semester. And what y'all can do is tune in on this Saturday I have a nice show for y'all. I'll share where I'm going for graduate school. I'll pull up the graduate school website. Y'all can see what the school is about because I know I'm going. Like I passed on my classes, got both of my degrees. You know, I met with my advisor. What Mon? What someday? When did we meet? What day is it? My days are all mixed up. I've been like moving, graduating, working, and I work overnight. This my schedule is all crazy. I'll be able to know what day it is. Today is Sunday. I don't even know what day it was, but I met my advisor. You know what? It had to have been Tuesday because it was after we finished finals and everything. And my advisor was like, "Oh, let's talk about what research what we have available for you for research and stuff." And the first thing he was like, "Oh, well, tell me, how's everything going right now? How everything ended?" And I don't know. Yep, got graduated, got my degree. So you can't go to graduate school unless you actually have a undergraduate degree. So I think he wanted to first confirm you passed, you got the degrees. Yep, I'm good. So at the time, I didn't finish getting all my grades yet, but I did all the calculations and everything, and I knew I at least passed. I don't know if I got my exam yet from quantum, but I knew I made at least a 20. So I knew I was going to get at least a C. So I knew I passed, and I got my degrees. So that was that. Yeah, but everything will start to settle a bit now since everything is yeah. So now I'll still be working of course, my learning assistant job is ended because the semester's over, but now I can work more hours as a security coordinator, so still be doing that over the summer, but it'll be a more stable schedule, so my sleep and everything will regulate again. So I had some good sleep early, by the way, Catherine. I totally lost track of time and everything. It was like I was in a different universe. I slept from when we finished talking until like an hour ago to get ready for the stream. Then so yeah, but thankfully I got some sleep. I must have got that's the most sleep I got in the past 3 days between moving, working, graduations. I was sleeping like 2 or 3 hours a day, and finally I was able to get like a good bit of sleep. So, but that was good. But yes, I talked to my advisor. I confirmed I passed, and we talked about our research. So I'll be able to talk about that with y'all on Saturday. I'll pull up the sort of the degree plans for their PhDs. We'll talk about that. So we'll go into detail about where I'm going for graduate school, what the degree is going to look like. I'm already registered for classes, so I'll show y'all what classes I'm registered for in the fall. And so I think it'd be a pretty cool show. And y'all be able to get an idea of some of the stuff I'll be talking about in the future. So over the summer, I actually plan on reviewing some of the stuff that I'm going to be doing in grad school, because as I said before, like you end up taking the same sort of classes again, but a higher level of everything. So I'm going to take quantum again, but it's going to be, at first we were just doing an atom in a theoretical particle in the box. And then for quantum two, we're doing actual particles in a well, like an electron by near a proton. So I don't know what we're going to be doing in graduate school, but it's going to be harder stuff. So I'll be reviewing the foundations of everything, probably going through some of the textbooks and stuff. So you can look forward to that for the summer. But then in graduate school, we'll keep it going. I'll still, we'll see how it goes. As you know, on my STEM channel, I probably do more graduate level stuff, and on this channel, do more undergraduate foundational stuff to that you have to understand the graduate stuff. So I'll still try to keep the sort of uh, delineation where this is a more general and the STEM channel is a more specific and complex stuff. So always good seeing you, Catherine. I do see a few people were popping in. Drop a line whenever you like. I'll put the link to the my graduation. It's already in the live stream. I put it in the uh, description as well. And I'll see y'all Saturday so y'all can hear about where I'm going for graduate school. It's a nice school, and uh, and then we'll get the topic shows going uh, every Saturday going forward. So awesome, awesome, awesome talking with y'all. I'll see y'all next time. And good seeing y'all always, Catherine. And y'all have a good one.